If you've ever been looking at arcade sticks on a budget, I'll bet that you've seen advice that goes like this. You don't need any of that fancy Japanese crap. Just go on Amazon, find a DIY kit for 20 bucks, and just build it yourself. Knowing the price of these parts are usually $20 a piece, seeing the entire kit for $20 left me extremely skeptical of the quality. Another issue I've seen with this advice is people tend to skip over or obscure other costs. They'll say, just go find a spare box in your house, or just use scrap wood. And I think this advice especially ignores the potential cost of tools that would be involved in the project. Another thing that sketched me out is that these sellers seem to frequently delist their kits and then re-upload them with a slightly different name or wording. This tactic is a favorite of sketchy sellers trying to hide negative reviews on their product because they won't follow over to the new listing. Considering the kit is only $20 and I had most of what I would need anyway, I was just too curious to resist. So in this video, we're gonna find out, what do you actually get in these super cheap kits, and is it really worth it? Are we all just ignoring some god tier savings? So to start, I moved everything into the box we're going to be using. It's a Kuggis from IKEA. It costs about $7.50 US. I also bought some nuts and bolts from my local hardware store. The kit does not come with any mounting for the joystick, so that's what they're going to be used for. Here's an example of the buttons that it comes with. You can see they're both 24 and 30 millimeters here. The first thing that stood out to me is they're legitimately tactile. I was expecting ones like what came out of the 8-bit Do arcade stick, which are completely typical of Sanwa clones. They have a bit too much friction, they grind a little, etc. But while these are stiff, they're surprisingly not bad. For unrelated reasons, I was looking at IST's website. If you're unfamiliar, they make a lot of nice Korean levers. And I noticed they make buttons which I'd never seen mentioned anywhere. It immediately struck me how similar they looked to what was included in this package. IST is upfront about what these buttons are. They explicitly call out that they are OBSF clones. The goal seems to be to make reasonable quality buttons for OEMs and regional markets with less buying power. They only cost $1 US, so I added some onto an order that I was already going to make. When they got here, I opened them both up, and sure enough, they both have the same style of switch inside them. The IST buttons are linear and the switch is a mint green color versus the tactile white ones that came in the DIY kit. I think this is like how Omron uses gray and white for their ROM or Gs, although I cannot figure out who manufactures these switches. While the 24mm button is a dead ringer for IST's 24mm, the 30mm buttons are all low profile, and I didn't see anything on IST's website that looked like that, but they do bear a suspicious resemblance to Suimatsu's PG-14 buttons, so my best guess is that these are Frankenstein together from other companies' buttons. Looking at the joystick, it's clearly a JLF clone. The kit comes with a ball top and only a single washer. If you weren't aware why some sticks come with two washers, it's because one is supposed to go inside of the case while the other goes out on top of it. There are two extra gates, an octagonal and a circle, and they look to be exact copies of Sanwa gates. The first thing that stands out is how weirdly tall the shaft is on this. It's especially obvious side by side with a real JLF. It confuses me how with some parts, the kit seems to meticulously copy whatever it's ripping off, but other times it will deviate without any clear reason. Given how cheap this kit is, I have to assume the reason always comes down to cost. I know Suimatsu makes replacement shafts that are taller than the default, and we've already seen parts that bear more than a resemblance to theirs in here, so I have to wonder if these are more knockoffs or maybe even factory seconds. Another weird thing is the included washer is too small to work with a shaft cover. I'm not sure why they would choose to cut it smaller. I realized this after filming, but I think this is another Korean part. You can see here on my Conma Dragon, I have a knee lever installed, and looking at them side by side, the washers appear to be cut to the same diameter. Comparing them side by side, I think the clone has a slightly longer throw than a real JLF, but that could be my eyes. If there is a difference, it isn't massive. Looking at the bottom, it seems they've made the actuator from the same orangey plastic that the inner part of the gates are made of. Not sure what that's about. And this is the smallest E-clip I've ever seen. It's clear the manufacturer never intended for this to be taken off. I have to use my smallest flathead to even get part of the way into the E-clip. Once I get into the joystick, I realize there is grease all over the inside. It's inside the actuator, it's on the spring, it's all over the shaft. This is unusual because cheap cloned joysticks usually lack much or any grease. Quality silicone grease isn't cheap, so it's an easy thing to cheap out on and cut costs. But this joystick is absolutely coated in it. So I knew something was up with that. When I try and get the gate off, I'm unsurprised to find that the body plastic is very stiff. And stiff plastic is usually brittle plastic, so I have to be gentle to not risk breaking things. Under the gate, we have switches made by Zing Ear. This stands out because SJ at JX has branded just about everything in this kit with their own name. Looking Zing Ear up, they do seem to be a company that makes micro switches, though their primary business appears to be pull chains for ceiling fans, of all things. I'll point this out to SJ's credit because I think this is an intentional choice. Given they paired the stick up with low-profile buttons, I think they've correctly assumed their average buyer is going to be installing these parts on a smaller case, and having the connector go down instead of off to the side is going to save on surface area on top of the stick. Further into the stick, there is even more grease. More than that, there's condensation around it. Between the condensation and that it appears to be draining out of the cam housing, I think I know what's up, and I confirm my suspicions when I am able to wash it off my hands with nothing but water. This is a water-based grease, more commonly known as personal lubricant. Despite getting a laugh out of it, I have to give SJ credit. This is actually pretty clever. Rather than leaving the cam basically dry like most manufacturers do, they pumped a bunch of cheap lube in it. I put the stick back together after evenly reapplying the grease and tested it out next to the real JLF. While the joystick is pretty subpar, I'm actually surprised it's better than I would have imagined. Moving on to the board, it's one of the many cheap, generic, zero delay PCBs and an accompanying power cable. We should talk about what zero delay boards are for a moment. I'll link this in the description. It's a comprehensive Google Doc put together by Mr. with all sorts of data about different boards in it. I need to emphasize there are tons of different variations of this same kind of board floating around, and trying to cover all of them would be impossible. There's a similar one on the list. It's the Rayan Zero Delay. Given it has an actual name associated with it and a few nicer features like a USB power adapter, this is arguably as good as they get. The thing is, the delay on these boards might be close to 0 milliseconds, or it might not. You can see in Rayan's minimum measured response time, I'm going to link it up here, you can see that Rayan's minimum response time when measured was about 0.2 milliseconds, which is great. Its maximum was 42, with a standard deviation of 12 milliseconds between inputs. It also never achieved a same frame input. These are optimal results, they're still bad, and I doubt the board we get in this kit is even half this good. This deserves a video of its own, but people put way too much emphasis on selling points like real Sanwa parts instead of the boards. Because the board you hook the buttons to is what's really going to determine how precisely the inputs are transferred from the stick to the system. The peripherals like joystick and buttons really do come down more to personal feel and preference. There's a problem with the wires included though. There's no insulation on them. So they can, among other things, cross one another and generally be an electrical hazard. And then we also have the 5-pin for the joystick. So I'm gonna end up having to insulate these wires myself. I took a heat shrink gun and some heat shrink tube, cut it down to size, and fit the tubing to the connectors. I put all the wires in according to the product listing because no guide comes with it. There's nothing interesting about that. They all just run down the one side. Alright, that is everything about the parts included, but now I have to drill holes out. This part took me a lot of time and very little of it is going to be interesting to you. Because it's just me doing the same thing slowly and carefully to not accidentally cut anything too large. I'll try to cut it down to the key points. The IKEA box is not big enough to fit the buttons and the joystick in a normal Vuelix layout. I printed this guide out from slagcoin.com. They have all sorts of arcade layouts there, so check them out. I need to cut this guide and move the joystick hole over a bit. I start by drilling out smaller holes in the center where the buttons are going to go. This is to help keep the step drill from walking while I'm trying to drill out the actual holes to the right size. You can see the step drill bit here. Through the entire process, I repeatedly cut smaller than I think I need, double check, then cut more if I actually do need it. It's tedious, but it keeps me from ruining any of these holes. Once the main holes are done, I need to figure out the mounting holes for the joystick. This part is even more tedious. It requires using a level to make sure the mounting plate sits completely straight. Otherwise, if the stick is crooked, the direction will be off, and a down could become a down back, for example. I mark the mounting holes with permanent marker, then do one corner at a time, peeling the tape back I'm using to hold it in place. Once I'm done drilling those, I countersink the holes so the screws will sit flush. The holes that I drilled initially weren't wide enough, so I do go back and fix those. Now I thread the nuts and bolts in finger tight, then I use a small spanner to hold the nut in place while I tighten the screwdriver. The buttons are way easier, they just push in exactly how you would expect. I put them in to match a standard PC or Xbox button color layout. Then I screw in the ball top and cover the screws with some white electrical tape, just to put a little something more between my hands and the screws. Then I will refer back to the picture in the product listing to make sure I hook all the wires up correctly to the buttons. Alright, so that does it for the actual build portion of this. The only thing left to do is to actually try it out in some gameplay. I'm going to play some Tekken and some Strive, so I'm going to cut right over to that. Real quick, this is about the 2/3 mark of the video. If you're here and you're enjoying the video, please leave a like and consider subscribing. I gotta plug it somewhere. Okay, with that, now I'm legitimately going to cut you over to the gameplay. Alright, so I kind of have a plan to test this thing out. So, I don't really know very much about Lars. I thought that would make him a good one to test out. We're going to do a couple sample combos. These should be pretty easy. I want to go after these sample combos for a reason. They're like the basics, the things that you should be able to do. So this thing, if it's going to be in any way a competent arcade stick, it should be able to pull these off. I noticed one of the things it really doesn't like doing is it does not like multi-button attacks like that. Sometimes it seems like I hit a button and just nothing happens. Okay. Yeah, what I'm noticing is when I go to do this cross like that, I'm getting like you really gotta mash both of them down. No. There it is. Okay. Alright, I got it. That's good. Alright, let's try the next one. Alright. Okay. Got that one out. Missed that one. That was me doing it wrong. Don't know what that was. Alright, let's try doing application of Roman cancel again. That, I think it's a good one to test the stuff out. Application of Roman cancel has most everything that you would want to test on. It has really quick frames, it has several different motions, it has kind of odd timing spacing in places, especially around parts 6 and 7. No, that didn't go through. Okay. Alright, good. Good. Cool. Oh, that was me. Okay. I think I would have had that last one if I didn't mess it up. After realizing the washer was from a Korean lever and pulling my dragon out just to show the similarities, I figured I might as well try it out and just compare the experience. I have an IST knee lever on the dragon, which is indisputably high quality. However, it's new to me and the feel isn't completely to my style, or at least it hasn't grown on me yet. I point that out because I think it makes a good comparison with the joystick that came in the DIY box. It's a lever I'm not familiar with, but is clearly of good quality, and the Dragon has a great board, so I know there won't be issues there. I noticed an immediate improvement in my play. Moves I swore were dropping or coming out late, specifically the wall standing 2 and the down forward 2, which felt super inconsistent on the $20 stick, weren't an issue anymore. Considering my total unfamiliarity with Lars was a part of the test, I'm sure some of it was me dropping the combo, but I think this confirms it wasn't only me. Alright, so I have to admit, I had a lot of fun putting that stick and video together, but is the stick worth it? No, it's total dog shit. But let's say your only concern is, can it be done? Can you build an arcade stick for $20? The answer is technically yes, but realistically no. My personal guess, and it is a guess, is that this kit is a collection of factory seconds or cast-offs from production of multiple other arcade companies. During this, I found parts that looked like they came from Sanwa, Shimetsu, and IST. I always try and be fair, so I have to admit, this stuff feels a lot better than I'd expect for $20, but don't confuse that with any sort of praise. I felt worse, but it's not the worst is not worth the amount of time and effort that went into making this thing. And don't worry, we're getting to the worst. Assuming you have everything but the arcade parts, yes, you can do it. But I figure most people are going to need a case, and the $750 I spent on the Kuggis I think is a reasonable estimation of that cost. With tax, we're already closing in on, if not at, a $30 mark. And keep in mind, the Mayflash F300, the cheapest arcade stick you'd actually want to buy, is $60, and that is the price to beat here. Maybe your uncle is Tim the Tool Man and you can borrow all this. But if you have to buy even some of these tools, you are going over budget. I think even the most tool-deprived households have some flatheads and Phillips screwdrivers in them, so I won't count those. But let's go over everything else. A power drill, drill bits, a step drill bit, wire strippers, insulation, a countersink, a level, and I'm probably forgetting some other stuff. Point being, this is a tool-heavy project. If you need to buy any of the big ticket items, you're obviously going over budget, but even a few of the smaller ones will easily add up to $20 or $30, and then I think it's hard to come up with a reason why you aren't just buying an F300. Take the step drill bit, for example. This isn't a common tool, so I suspect most people will have to buy one. Reputable companies usually make them to handle metals, so they're typically made out of titanium, and titanium isn't cheap. Mine cost around $50. If you look on Amazon, you can find step drill bit sets of 3 for $30. While they'll probably go through plastic, if they don't have a good edge, they're more likely to crack it than cut it. And that's not even considering that buying them will put you over budget. So, in conclusion, if you are trying to save money, this is almost certainly not the way to do it. Alright, that was the video. If you enjoyed it, would you please let YouTube know that by pressing the button right down there? And I won't take up any more of your time. Hope you enjoyed it, and I'll see you in the next one. Bye.